Today on How It's Made. Halogen bulbs. Making them is a truly brilliant process. Cellulose insulation. We thought it was time to fit this one in. Aluminium ladders. Finally, this programme is on the way up. And bamboo fly rods. We cover all the angles to look at their construction. But first, halogen headlights are a shining example of progress. The halogen bulb throws cool white light that mimics daylight illuminating the road ahead. And because they're energy efficient, they don't burn out too often. A real plus when you're trying to keep your eye on the road. To make a halogen headlight, mechanical jaws load 3 lead wires into a machine. A gripper moves in and bends the wires at the bottom. Meanwhile, a conveyor system feeds small glass rods to a burner. The softened glass is now pressed onto either side of the lead wires, encasing them. Next, a welding head fuses tungsten coils to the lead wire assembly. The coil is the filament, the part of the bulb that emits light. At another station, a mechanical arm loads a glass tube into a machine head. A burner aims a flame at the centre to soften it up. Then, mechanical heads pull the glass at both ends as the burner continues to fire heat at the middle. This creates a neck in the tube. Now, mechanical arms position the coil and lead wire assembly under the newly shaped glass tubes. Grippers lower the glass tube over the wires so they sit under the neck. Burners move in and encircle the glass at the bottom, softening it. Then a press seals the glass around the lead wires, which protrude from the bottom. Next, a test. An electrode sparks the lead wires. When the capsule illuminates, it means there's ambient air inside that would interfere with the bulb's function. Vacuums at the top of the bulb suck out all the air and contaminants. Then nozzles spray liquid nitrogen onto the bulb. This freezes it inside and out, creating a pressure difference. That change in pressure pulls halogen gas into the bulb from a chamber above. Allowing no time for the gas to escape, burners heat seal the bulb at the neck. The bulbs then cool as they move on a transfer chain. Grippers now load the bulbs into another machine. A pusher moves up and snaps a steel retainer around the bottom of each bulb. Meanwhile, another machine builds the base for the bulb. It pushes electrical contacts into the plastic receptacle. This is the view from the bottom. These prongs will eventually connect the headlight to the vehicle. Next, jaws turn the bases over. They load them onto a tray on tracks. The tray delivers the plastic bases to a mechanical arm that installs metal retainers on each one. The bases slide forward, and the machine inserts the glass bulbs into them. But it's a loose fit. This machine aligns each bulb to its base. Jaws tilt and slide it into place. Then a laser welds it together. The alignment is critical. Coils for the low beam and high beam mechanisms must be precisely positioned. Next, a series of claws pick up the bulbs and dip them in an opaque coating called black top, because it only covers the tops of the bulbs. This will direct light out of the sides of the bulbs. Now it's time to take these bulbs for a test drive. A bracket holds them down while probes underneath energize them to make sure they work. A plunger places a gasket around the base. This will seal the headlight capsule to the car. And now they're ready to shed some light on the situation. One type of insulation material is cellulose fibre, made from recycled paper. It's derived from a natural source, wood fibre, so it's non-polluting. It contains no asbestos, no fiberglass, and no formaldehyde. Insulation keeps your home warm in the winter and cool in the summer. Like other insulation materials, cellulose fibre has to meet strict government safety standards. One fire safety test assesses smoulder resistance. A sample from the production line is weighed, and then a lit cigarette is inserted into it. Once the cigarette burns out, after about an hour, the sample is weighed again. The weight loss must be less than 15%. Making cellulose insulation begins with recycled paper, delivered in bulk. It's loaded by hand onto a conveyor belt, and from that point on, the entire process is automated. The paper goes into a machine called the primary mixer. It separates the bunched up pieces, preparing them for shredding. The machine's powerful magnet removes staples, paper clips, and other pieces of metal. From there, the paper goes into a shredder, which rips it into pieces about 5 centimeters long. The shredded paper is mixed with boric acid, a natural compound that acts as a fire retardant. It also makes the insulation pest resistant, and it helps fend off mold, wood decay, and corrosion. Now a machine called a fiberizer shreds the paper into tiny pieces about 4 millimeters long, and it mixes them with more boric acid. From the time the recycled paper arrives by truck to the time it comes off the line as cellulose fibre insulation, only about 5 minutes have passed. The insulation doesn't leave the factory before undergoing thorough safety testing. This test assesses what's called open flammability. The insulation is heated to 50 degrees Celsius to stimulate the temperature of a roof in the hot sun. Then it's ignited. The flame travels but then dies out, thanks to the boric acid. If that happens within a certain distance, the insulation is safe. Outside research firms also test the product for safety to verify the results of the company's tests. The automated packaging equipment blows 11.3 kilograms of insulation into a bag, whilst at the same time compressing the fibre into a block. Some types of thermal insulation come as thick rectangular blankets known as bats. These will be installed by hand, fitting snugly between the wall studs. Cellulose fibre doesn't come in bats. It's known as loose fill insulation. A professional installer has to inject it in between the walls by spraying it in under pressure. It fills all the spaces without any gaps, something that's hard to do with pre-shaped bats. Insulating performance is referred to as R value. The higher the R value, the more effective the insulation. Cellulose fibre insulation has a higher R value than loose-fill mineral fibre insulation, and a similar R value to loose-fill fiberglass. Cellulose fibre is denser than other materials, so it resists air movement better, making it less likely to move out of place after installation. And it saves money on your heating bills. Coming up on How It's Made, aluminium ladders. We take a look at each step of production. And bamboo fly rods. Make sure you catch this one. See you after the break. The aluminium ladder is the height of convenience. Lightweight and sturdy, it makes any ascent easier. Wooden ladders used to be standard, but were extremely heavy, difficult to position, and would eventually rot. The use of aluminium took things to a whole new level. For a ladder to really stand up, the aluminium needs to be strengthened with these ingredients: silicon, magnesium, manganese, and copper. It all goes into a furnace. A crane transports a hopper full of aluminium over to the furnace. The hopper opens at the bottom to unload. A door is opened at the front of the furnace. The operator wears a face shield to protect him from the blistering 700 degrees Celsius heat. He adds the other ingredients, and the heat turns it all into a liquid mass. The liquid flows out of the furnace into troughs. It seeps through holes in the troughs to moulds in the ground. The liquid cools and hardens in the moulds. This makes log shapes that are almost 7 meters in length. A hydraulic lift extracts them from the moulds and slowly takes them to the next station. You wouldn't want to rush this job. Each log weighs 500 kilograms, and dropping one could do serious damage. A saw cuts them into pellets. The size depends on the type of ladder being made. A mechanical lift delivers a heated pellet to an extruder, and a ram pushes it into the opening. They move the die plate into position. The ram forces the hot pellet through holes in the die plate. This makes a rail shape 40 meters long. A puller drags the rail onto a table and leaves it to cool and harden. Then, a circular saw slices it into manageable 6-meter lengths. Each end of the rail is fed to jaw systems, which pull it to make it completely straight. The straightened rails now move on to the next station, where plastic feet are riveted onto the ends to keep the ladder from slipping. Safety information is stuck onto the rails, and the ladder is assembled, one step at a time. Each step is fitted in the rims of the ladder rails, then riveted in place. This will be the front of a light-duty stepladder. A diagonal brace is installed, and the ladder is turned over so that the steps can be riveted from the other side. A sturdy blue plastic top is fixed onto the front and back pieces, joining the two. The spreader is also installed and secured with rivets. And now, this stepladder is ready to provide a little elevation. For a lot of elevation, extension ladders are produced. Cylindrical rungs are used for greater strength. Each rung is fed to a machine which tapers the ends. Another machine presses aluminium ferrules onto each end. This allows the rungs to fit snugly into slots in the extension ladder side rails. Hydraulic arms reach from above and below to press fit the rungs into the side rails. Finally, workers rivet rubber pads onto the ends of the rails. This provides a firm footing for the ladder. These ladders are now complete, and if you're on your way up in the world, they'll come in handy. The bamboo fly rod is a classic. The split bamboo rod has been around since the early 19th century. These days, synthetic rods abound, but bamboo still holds a traditional appeal. People buy the idea, hook, line, and sinker. A bamboo rod is considered a work of art in fly fishing circles. To begin the process, a craftsman toasts a bamboo pole on an open flame. He holds it close to the fire, but not too close. One false move and he could scorch it. The goal is to turn the bamboo a golden brown. He pounds a wedge into the toasted bamboo and drives it down the length of the pole. The pole is pulled apart, splitting it in two. Then the craftsman continues to split the bamboo, making strips that are less than a centimetre wide. The bumps on the exterior of each bamboo strip are ground down using a belt sander. Next, it's over to the milling machine, which tapers the underside of the bamboo strip, beveling it to a 60-degree angle from end to end. This critical step will affect the rod's casting performance. Each strip has to be perfect. The rod maker inspects them for flaws and then fits 6 together in a hexagonal configuration. He wraps them with cotton twine to hold them together very loosely at one end. Then he dips the bamboo strips in a tank of thermo-setting glue. He feeds them to a twining machine, which binds the strips tightly together. It's a temporary wrap, a kind of clamp, to hold the pieces together while the glue dries. The pieces are now laminated into one, but the result is never perfectly straight, so the rod maker heats it over an open flame. The heat softens the bamboo, so the kinks can be smoothed out. Next, ferrules made from nickel silver are glued onto the laminated bamboo pieces. This tubing will be used to connect the tip and butt of the rod. The butt section now turns on a lathe, while a blade cuts into it. It's slimming down sections to accommodate the handle and reel seat. The walnut reel seat is slipped in place, and cork rings are slid onto the rod to make the handle. Each ring is glued. It takes 12 to 14 to make a handle for the typical bamboo rod. It will allow for a soft, non-slip grip. Once the glue hardens, the cork is shaped on a lathe. It's sanded to give an even finish. Next, some glue is heated over a flame. The hot glue is applied to the stainless steel tip and stuck on the narrow end of the rod. The model and serial number are applied onto the rod using black India ink. Now it's coated with varnish using a turkey baster. The rods are left to dry. It will take 3 coats of varnish to give them a nice gloss. Silk thread attaches the steel guides to the rod. These are the loops that the fishing line will go through. 3 coats of varnish are brushed onto the string. This solidifies the wrap and fuses it to the rod. A ring is slid onto the reel seat to provide a little separation from the cork grip. The butt and tip pieces of the bamboo rod are fitted together. It's taken 40 hours to make this bamboo fly rod. Now it's just a question of how long it will take you to catch that big one. So, whether you're looking to shed a little light on the situation, or hoping to maintain a steady temperature, or you're trying to climb to new heights, now you know how it's made.